Hi everyone, so we are live. Hi everyone, welcome back to Code Era. Today in this video we'll be discussing the problem that is subarray sum equals k. This problem previously has been asked in a lot of organizations like Google. It has also been asked in Microsoft. It has also been asked in Amazon and a lot of other companies like Uber as well. So consider giving me a +1 in the chat if my voice is clearly audible to everyone and the screen is visible, and then we can start with this particular problem, right? So all of you can just give me a +1 in the chat if my voice is clearly audible to everyone and the screen is visible, so that we can start with this problem as soon as possible. So in this problem what you have to do is you will be basically given an array and you have to find all those subarrays. You have to return all those subarrays. Basically you do not have to return, but you have to count the total number of contiguous subarrays whose sum is equal to k in this particular problem, right? Hi Samadhan. Right, so this is the problem. I'll let you know. So this problem, as I told you, like let's first of all mention which companies have asked this particular problem. So it has been asked by Google. Apart from this, it has been also asked by Microsoft. It has been asked in Amazon, Uber and Meta. Apart from this, a lot of other companies have asked this as well, but these are the primary companies that have asked it more frequently, right? So this is the problem. The problem is that you have to count all subarrays with sum k, right? With sum equal to k. You have to take the count. You have to count all the subarrays who have a sum equal to k. Like Nandu, how is it crystal clear? I haven't started even, right? So what you have to do is you'll be given an array of integers, that is nums, and you will be given an integer k. You have to return the total number of contiguous subarrays whose sum is equal to k, right? Let's say the nums array was 1 1 1, like this. If the nums array was like this 1 1 1, then if the k value was 2, so you have to return the count of all the subarrays which have a sum as 2, right? Which have a sum as 2. All the contiguous subarrays which have the sum as 2. So in this case you can see that this is one of the subarrays which is having sum is equal to 2, right? Starting from the first index going to the second index, like this. Then there is one more subarray that is starting from the second index and going till this index. Its sum is also equal to nothing but 2, right? So these two are the arrays which have sum equal to 2, that is equal to k. So there are two subarrays, right? I hope that this particular part is clear. Now let's discuss one more case. Like if we have 1 2 3 and we have k is equal to 3, like something like this. Let me draw it for you. So this is a very easy problem actually. So if you have 1 2 3 and your k value is equal to 3, in that case you have to do what? You have to count all the subarrays. You have to count all the subarrays. You have to take a note of all the subarrays which have the sum equal to 3. So if I take it this way, so I can say that maybe I can do for a prefix sum. For the starting part I can do a prefix sum, right? So how I can do a prefix sum? Like this. Prefix sum means sum of all the elements till that particular index, right? So if the prefix sum I talk about here, so the prefix sum seems to be 1. Then if I talk about this part, so prefix sum is nothing but this index plus the previous indexes plus the previous prefix sum, that is nothing but 3, right? Here the prefix sums comes out to be 6. Can you tell me how many subarrays are there in this particular array which have a sum k is equal to 3? How many are there? First of all, you can notice that this is one of the subarrays, like this subarray till this subarray. This subarray is one of those subarrays which is having sum is equal to 3, right? This is one of the subarrays. Another subarray is this subarray itself, right? So there are basically two subarrays, right? Two arrays, two subarrays, whatever you can say, right? There are two contiguous arrays which have sum is equal to 3. First one is this one, from 1 to 2 you have the sum as 3. Then this single element 3 will also give you that, right? Please give me a +1 in the chat if this much part is clear to everyone, right? Is this much part clear to everyone? Okay, this is the problem. Now in this problem, if you will observe clearly, so I have told you about one thing. That one thing is what? I'll let you know. If I say that if I just let me remind you of something that I've taught you previously. So I've taught that if the sum from here till here is sum, right? Then what will happen? If the sum from this index, from the starting till the end, is sum, then the sum from here till here, if it is also sum, if suppose that this much part is sum till this index, the sum is sum, the prefix sum is sum, and till this index, if the prefix sum is sum, so that means that this particular from here till the end of the array, I'll have what? From here till here, I'll have the sum as what? I'll have the sum as 0. Can I say this? I have told you this, right? So if I had to, we had done this question, right? Where let's suppose that if you had to count all the subarrays with the sum 0. So we had done this question, right? Can you relate it to it? Like you can, if the sum was equal to 0 itself, if the prefix sum is 0, then in that case you can keep a count. But if you are at a current index that is having a sum as sum, and you also have seen a particular sum earlier as well till some index, so that means that the sum of this much array, this much subarray would be what? 0, right? This much part is clear. So similar logic you will try to apply here as well. What I'm saying here, I'll let you know. What I'm saying is, let's say that you have elements that is 1, 2, and then you have 3, right? And you calculate the prefix sum. So you also have a track of the prefix sum. So the prefix sum, initially let's say here the prefix sum is 1, right? Here the prefix sum would be 1, here it would be 3, here it would be 6, right? So what I'm saying is, earlier what you were doing, you were checking whether the particular up till wherever you are, that whether that sum is existing or not. But here you will check something else. Now can you see that this 3 is also a subarray which is having the sum as k, where the k value is 3? Yes, it is having, right? What you can do is you will check first of all that if a particular prefix sum is equal to k, then in that case you will increment your count. That would be one of the ways to increment your count, to do count plus plus. That would be one of the ways, right? To increment your count, the one way could be this, right? This could be one way, that if the prefix sum up till there is equal to k, then in that case you will increment your total number count, right? Otherwise there could be one more ways, that if you have subarray and if you need to check that, so let's suppose that you are currently, your prefix sum is 6, so you will do what? You will do prefix sum, you can say you will do prefix sum minus k for every index. So suppose if the prefix sum is 6, right? If the prefix sum is 6, so if I do 6 minus 3, what do I get? I get 3. What does it mean? It means that if I have the current prefix sum is 6 and if I subtract 3 from it, right, else k minus I present in the array. What are you saying, Nandu? Right? I hope that this part is clear. Basically what I am saying is that if what I'm saying, I'll explain you through the help of a diagram. So I'm saying that from this index till in this index, let's suppose that you have the sum is sum, right? Now earlier you were finding that whether 0 is existing or not. So you were saying that till this much, till this part, if this part is sum, then this part till this part will be 0, right? But what I'm saying is, now you want to see whether k is existing or not. So for that what you will do is, you will check that whether there is a subarray that is having sum minus k. If there is a subarray which is having sum minus k, then this particular subarray will have a sum as k. Then only the overall sum would be sum. Because this will be what? This would be nothing but total would be sum minus k plus k. So it would ultimately come out to be sum. That is the sum of the whole subarray. Is this much part clear to everyone? Please give me a plus 1 in the chat if this much part is clear to everyone, right? Is this much part clear to everybody? You can give me a plus 1 in the chat if this part is clear, right? What I'm saying is, if you have a particular sum up till a particular index, right? If you have a sum up till a particular index, then what you can do is, you can have, if you have sum minus k up earlier existing, then only this part would be k, right? You want to find the subarray which is having k. Earlier your k value was 0, right? Earlier, suppose that your k value was what? I will let you know. Earlier your k value was 0, right? If you wanted to find all the subarrays with sum as 0, so what you could do, either you could check whether your sum is 0 or not, or you were seeing that if this much part is sum and this much part is 0, right? So here also that same concept is applying, because you were doing this like this, right? That if up till here the sum is sum and this much part is sum, so that means the leftover subarray that I have is having a sum as 0, right? This is the part. But what I'm saying is, what I'm saying is that suppose that this was k, right? K was here 0, that's perfect. So if k was 0, right? So that means sum minus k was also sum. So that was the case. But what I'm saying is, instead if this k can have a other value, so that will also work. Earlier the k value was 0. So this was becoming this part, right? So you were saying that this subarray is also one of the subarrays, right? So you were counting it. But now the thing is that your k value is not 0 here. So your k value is existing. So that's why this would be sum minus k, right? Is this much part clear to everybody, right? Earlier you were doing what? I'll explain it once more for the better concept clarity, right? If from here till here, if you have the sum as sum, if up till here the sum is sum, from here till here, if the sum was sum, you had also seen this kind of a sum, then from this part till this part the sum would be 0, right? So suppose that this was k, suppose that this was k, if the k was 0, then sum minus k would be sum only. So what I'm saying is, now you can apply the same logic, but instead of checking whether the sum was existing previously or not, whether you have seen a particular prefix sum which was equal to sum or not, now you will check this particular prefix sum, that is sum minus k, so that now this segment could be k, right? Is this much part clear to everyone? I hope that this minute part is clear. That is, if till from the starting up till the end, if the sum was sum, so that means if a particular scenario was having the sum as sum, then this much part would be 0. But here what I'm saying is, assume that k would be 0, then in that case what will happen? This sum minus k would be equivalent to sum. But suppose that you have a k value, you have k value that is existing, that is not 0. So this would be, I will check for sum minus k instead of sum. I'll check for sum minus k. If I'm at the current sum, so I'll check two things. If my sum is equal to k, if the current sum that I am at, if it is equal to a k, then I'll do count plus plus. Or I have seen this particular sum previously, that is if I have seen sum minus k previously, then in that case also I increment my count, right? Because the 0 subarray here would exist, and similarly here I wanted a subarray of sum k, it is existing, so that's why I'll increment my count for this as well, right? This is what I will do. Now let me take a little bit of example for that. Let's take a little example and try to see what happens. Let's say if I have 1, if I have 2, let's say I had something like let's say I had something like -1, then let's say I had 1, then let's say I had 3, something like this. Let's say I had something like this, right? What I'm saying is, you need to find the count of all the subarrays that are having sum as 0, right? That sum as 3. Let's say k value is 3. So you want to find all the subarrays which have the sum as 3. So let's do it for prefix sum, right? Let's do it for prefix sum. So here the prefix sum is 1. Here the prefix sum is what? Here the prefix sum is 3. Here the prefix sum is what? Here the prefix sum is 2. Here the prefix sum becomes 3 again, and here the prefix sum is 6, right? So now what I will be doing is, I'll be inserting all those things in a map as well. So now let's do it again, but I'll keep on checking. So I'll say, okay, the prefix sum is 1. So, but that is not something that I want, right? I want the prefix sum is 3. Here the prefix sum comes out to be 3. So I'll say that my count is equal to 1. I'll say, okay, there is one subarray. That is this particular subarray, 1 to 2. This particular subarray is having sum as 2. Sum as this part, right? Sum as 3. Now, what could happen? I move to this index. Now what will happen? I'll have 1 and 3 in my map. I have in my map 1 and 3. I have in my map 1 and 3, right? Now what I'll do is, I'll come here. So I'll say the sum is becoming 2. Do I have seen a 2? If the 2 was existing in this map, so that will mean that if 2 was existing, in that case, like, I need to check whether sum minus k is existing or not. I need to check whether sum minus k is existing or not. So the current sum is 2. So is 2 minus 1, that is if is 2 minus 3 existing? 2 minus 3 is equal to -1. Is it existing? No, it's not existing, right? Notice here I don't need to check for sum, I need to check for sum minus k, whether it is existing in the map or not. If it's existing, so that would mean that I've seen it previously. If up till now things are pretty much clear to all of you, so you can let me know in the chat. So this is what I'm doing. It's not existing. So I'll say, okay, it's not existing, no problem. So I'll say, okay, I have also seen a 2, and I'll have the frequencies, right? I'll have the frequencies instead. So I'll say that I have seen 1 one time, I've seen 3 one time, I've seen 2 one time. Now I'll come to this particular index. So I'll say that, okay, what's the prefix sum? The prefix sum here is 3. If the prefix sum is 3, then what will happen? If the prefix sum is 3 here, right? So in that case, I'll do a count plus plus here as well, because the prefix sum becomes 3. So this becomes 2. Now next up, what will happen? if the prefix sum here till here is 2. Now if the prefix sum till here is 2, so I'll do 3 minus 3. So do I have a 0 in my map? No, I don't have. So I'll say no problem. I'll say okay, let's increment the count of 3 because I've seen 2 prefix sums with 3's. So I'll say okay, 3's count is incremented to 2. Now I'll come to this particular index. What is the prefix sum? Prefix sum becomes 6. So if I'm at here, so the sum is 6. Since the sum is 6, so what will happen is that 6 minus 3 would give me 3. So do I have seen 3 as well? Do I have seen? So what does it mean? Like from this index, from this subarray till this subarray also I am having a sum as 3. What is the subarray? That subarray is nothing but 1, 2, minus 1 and 1. This particular subarray also that I have 1, 2, 1, 2, minus 1 and 1. Right? 1, 2, minus 1 and 1. This particular subarray is also having a sum of 3. Right? So I have counted it. So up till now that's why my count is 2. But do I have more such subarrays? So I have seen that okay, for this particular index, I also have the sum as 3. That is, sum minus k is existing, right? Sum minus k is equal to 3. So that means that for this particular as well, I'll have it because sum minus k is equal to 3 and it is existing 2 times. So earlier the count was 4, now 3 is existing 2 times. So that's why I'll increment it to 4. But wait, where are those two? No, those two arrays as well, those two subarrays as well, which will have the sum as 3. So I'll let you know what are those subarrays. So those subarrays are nothing but one is this subarray, that is this subarray, that is only 3 and element 3 that you have. This is one of the subarrays. That's why you have the sum here as 3 and here as 6, right? So this is one of the subarrays, right? This is one of the subarrays of the 2 subarrays that I have counted, right? So this is one of the subarrays. Another subarray is this subarray, that is minus 1, 1 and 3. This particular subarray is also there that I have. This particular subarray, it is also having a sum as 3, right? Can you notice this? So total I have counted all the subarrays. I have counted all the subarrays. And how did I count them? Right, that's the challenge that I need to see. I had 1 and 2. This was one of the prefix arrays that I could see, like this 1 and 2. Then I checked for 1, 2, minus 1 and this, that is 1, 2, minus 1 and 1. This was also one of those. These were the prefix subarrays, right? These were from the starting that I could see. But I can also observe that apart from this, there were other subarrays as well, right? Like you can see that what are the subarrays? One is this 1 and 2. This is giving me a sum of 3. Another is 1, 2, 1, 2, minus 1 and 1. This is also giving me. But these are the ones that I am getting from the starting, right? But I can also get this. I can also get this. So that is why I am counting it. Like that's why my 3 was 2. So that's why my count incremented from 2 to 4. That's why, like I told you from the sum concept, right? If from here till here, the sum was sum, and this particular sum was sum minus k. If sum minus k was existing, if I've seen sum minus k, so that means this particular part would be k, right? I hope that it's clear to all of you. Please give me a +1 in the chat if this part is clear to all of you, and like the video as well. Please like the video. Right, now what will happen? Another subarray that I have, this subarray, that is minus 1, 1 and 3. This particular subarray is also having a sum of 3. So I have taken all these subarrays. These are the normal subarrays from the starting, right? These are the prefix subarrays, and these are what? These are nothing. This 3, 3 and 1, 1, 3. All these are the internal subarrays that I did not wanted to skip, right? So that's why I've checked them as well. You can like the video and please let me know if the concept is clear or not. I hope that it's clear to all of you. If you want me, so I'll explain the concept, I'll explain the chronology, I'll explain the concept a little bit once again, a little bit. Like in the map, you are doing nothing but you are storing all the prefix sums that you have seen up till now. Okay, what I've said is, earlier what you did, earlier, like we are recalling something. So earlier what you did, earlier we had learned in the previous session, one of the sessions, that if the sum from here till here is sum, and if the sum of this particular part is sum, so if I am at a particular index, current index, and I have seen the sum till there as sum, if the sum till there is sum, right, and I have also seen that sum earlier, so that will mean that the sum in this particular part, the sum would be 0, right? This is something that we had learned. This is something that we had learned earlier. Now I'm saying that you just relate it. So assume that this k is equal to 0, right? So you will write k here. So that will mean sum minus k, and k value is 0. So this will not affect. So similarly, you can have any other value of k, but this time instead of checking sum, you will check sum minus k. Does this make sense? Is this much part clear to everybody? You can just let me know in the comments. You can just let me know in the chat. I hope that this much part is clear to everybody, right? So that is what I'm storing in my map, and I'm storing the frequencies, right? Because as I said for this particular array, let me just rewind it. So as I said for that particular array that I had drawn, right? This particular array, that is this array 1, 2, minus 1, 1, 3, and let's say this particular subarray that I told you, right? So for this particular subarray, 1 was this, that is 1 and 2. 1 and 2 was one of them. Then 1, 2, 1, 2, minus 1 and 1 was one of them. Then minus 1, this part, minus 1, 1 and 3 was one of them, and this 3 was also one of them, right? So this is what I did. Is this clear to you, Shreya, as well? Please let me know in the chat. If it's clear to everybody, I can see a lot of people are watching. You can consider to like the video. Okay, so for doing this particular part, the time complexity would be order of n, and the space complexity would also be order of n, because we are using the concept of map. Let me show you the code part for that particular thing. So what I'm doing I'll show you the C++ as well as the Java code. What I'm doing is I'm calculating the prefix sum. I'm having a map in which I'll be storing the prefix sums, right? Dry run one example, like Samadhan, I have already dry run one example, so you can check out that, right? I've already dry run the example, right? That is 1, 2, minus 1 and 1 and 3. So you can check out this particular example by rewinding after this video is over, because otherwise it will take a lot of time for us, right? Now what I'm saying is I'll explain it once again, but just give me some time to explain the code part as well, because this is important. So I have an unordered map, right? Hash map. I have the count. Now what I'm doing, I am iterating through the array. Current, this is the prefix sum that I am calculating. If the prefix sum itself is equal to k, then I will do count plus plus. Otherwise, I also need to check if sum minus k is existing. If sum minus k is existing, then in that case, its count will also get incremented. And I then need to do what? I need to do some map of sum plus plus. That is this particular prefix sum. I need to increment its frequency in my map as well, right? Now, similarly, I'll be showing you the hash map in Java. So what you will be doing is, like, the same concept is there. So you declare the sum as 0, you declare the result as 0, you declare a hash map, then you initialize your 0 to 1 like this. Like this is very similar. If sum minus k is existing, then you do first of all calculate the prefix sum. If sum minus k is existing, then you increment in your result, and otherwise if this particular sum is also existing, so in that case also you do it, right? So that's the thing. Like, it's very much simple. Both are simple. So do you want me to dry run it as well? To Thoko, like, if clear? Yes, it's clear, man, right? Basically, let me tell you once again. Let's do a dry run once again of that particular case, so that you can understand it better, right? Let's say that if you had something like 1, 2, minus 1, 1. I'm taking the same example again for better clarity, right? What are the subarrays that you have which have the sum k is equal to 3? Let's try to check out. One subarray is 1, 2, right? Another subarray is 1, 2, minus 1 and 1. This subarray will also have 3. Then another subarray is minus 1, 1 and 3. This is also one of the subarrays. Then one subarray is this 3 itself, right? So these are the subarrays, right? Now, again, as I told you, so all those subarrays, again, this would be looking a little bit tiring, but still, like what I'm saying, if a sum till here is sum, and sum from here till here is sum minus k, although I explain things again and again, so that is because you never mug up these things, right? You get them naturally. If the sum from here till here is sum minus k, and the sum from here is k till here is k, then only I'll get the overall sum as sum, right? So this is what the concept is. So that's why I'm doing it. That's why what will happen, the prefix sum, if you will check, so let me draw the prefix sum. So prefix sum will, let me write it better way. So this would be the prefix sum. So prefix sum here is 1, 3. So I'll say, okay, prefix sum of 1 is 1, 3 is occurring one time. Then I'll say, okay, 2. So up till now the count is 1 because I have seen one prefix array, right? That is this. Here my sum is equal to 3. So count is 1. Now here the count would become 3 again. So that means that 3's frequency would change to 2. And now since I have seen 1 here, so that means what? I've seen for this particular array, I've seen for 1 to 2, and I've also seen for 1, 2, minus 1 and 1. Like, these are the ones that I've seen. All of you can consider to like the video, please. Right? This is mandatory for all of you. Now, another thing that I need to notice is, now I'll come here and I'll come at 6. So I'll see whether sum minus k is existing or not. You will keep on checking for all, but for all these other elements, it would not exist, right? So I'll check whether sum minus k is existing or not. Currently, my sum is 6. So I do 6 minus 3, so I get 3. Is 3 existing? Is 3 existing in my map? Yes, 3 is existing in my map. 3 is existing 2 times. 3 is existing 2 times. So 3 is existing 2 times. So that, what does that mean? That there would be 2 more sub-arrays. So that's why what I'll do is I'll do count plus is equal to map of sum minus k. Right, so that means count plus is equal to map of 3. So that means 3, right? This is what I'll do. Now why am I doing this? Why am I incrementing my count? First of all, there were 2 subarrays that we had already seen, right? One subarray was this, one subarray was this, like what? This subarray, right? This subarray. Another one was this. We have seen these 2 already, so the count is already 2. Now I am incrementing the count by 2 more, so that means 4. Why I am saying 4? Because the thing is there are 2 more internal subarrays. One internal subarray is this subarray. One internal subarray is this subarray. That is minus 1, 1 and 3. That is there with the sum as 3. And another internal subarray is what? Like you can see, right? If the sum till here is this, so that means if the sum is till here is 3, so that means this particular part is getting 6, so that means the sum till here addition would be 3, and that is the case, right? Minus 1, 1 and 3, so that gets me overall 3, right? So that's why I am doing it. Now another thing, like this is one of these subarrays, another subarray is this subarray, right? This 3 itself. So you can see that this element is itself existing, so that's why the count would be 4. Please write clear in the chat, please give me a +1 in the chat, please like the video if the part is clear to everyone, right? So this is what I did. Let me show you the code part again for better concepts. So if the sum is 0, then in that case what I'm first of all marking my sum as 0. So like karo. What I'm saying is unordered map I'm declaring. Now that is nothing but a hash map. Count is 0. You iterate through the array. You calculate the prefix sum. If the prefix sum is 0, then you will increment your count. We had 2 prefix sums, right? That we had, which had sum k. So that's why we were doing the count for them, right? Another thing is that whether sum minus k is existing or not. If sum minus k is also existing, so in that case you will not do count plus plus. You will do count plus equal to map of sum minus k, because there could be more than one subarrays, right? There could be more than one subarrays which could be there, right? So that's why you'll do, as I told you, right, that here we had minus 1, 1 and 3, right? This was one of the subarrays and another was 3, so we had 2. So that's why you need to do it with the frequency. That's why you need to store the frequencies, right? So this is what you need to do. In the end you just return. So let me submit this code, show you that it's working perfectly fine as I have already discussed. So you can see that it got accepted. So it was a very easy problem, I would say, but still, like, this concept is very much similar. I have told a lot of hash match problems to all of you just so that you can understand things better. So this was it for today. Also, if you think that we are doing something, if on this channel, if you think that I am doing something and others are also doing something that is different from the other YouTube channels or others, how others are explaining things, like they are explaining more of an in 10-15 minutes, but I am taking more time to explain everything, every concept, every thought process. I'm providing the code for Java, C++, everything. So if you think that we are making a change, consider to subscribe this video. You can maybe share it with your friends, maybe on some social media, maybe on Instagram, maybe on WhatsApp. That's voluntary, but if you will do it, so it will help us to bring more content. It will motivate us to work more hard on all these things, right? So this was it for today. Thanks a lot for everyone for watching. I'll see you soon in the next live. Till then, take care, keep coding and stay safe.